Hello, everyone. Good morning. Welcome to today's webinar. I want to welcome everybody to today's webinar. My name is Favor Ahamifula, and I'll be your host and moderator for today. So this session is titled Unlocking New Streams of Income, 3D Laser Scanning, a Great Opportunity for Surveyors. And I want to say a big thank you to OTIC Surveys in collaboration with Joso Technologies for hosting this important session. So before we start, I would like to note a few things about the session. The session is being recorded, so just in case you have network issues, you can't hear us, or you have network interference in your area, don't be scared, don't be troubled. A recording will be sent after the webinar. So just stay calm and enjoy the session. If you're logged out because of your network, you can join back using the link. And then we will be muted during the presentation. This is to ensure serenity of the presentation of the webinar so that we can hear ourselves and engage better. And also we'll be using the chat box. If you're using your desktop, you will below the screen, you will see a chat box icon. It's like a message icon, So we'll be using that to engage. So as the speakers will be talking, they'll be requesting you to do some form of engagement in the chat box. If you can hear them, you type, you can hear them in the chat box. If you can't hear them, please use the chat box to express that, okay? And then there's the question and answer session, the Q&A session. So as the speakers will be talking and the questions are coming to you, please drop them in the question and answer session. Please drop them in the question and answer session. So just to test that, if you heard everything I said, please type in the chat box that you heard me. Say I heard you. If you heard everything I said, I just want to be sure that we heard what I said, if you understood it. If you heard everything I said, please type I heard you in the chat box. Okay. That's wonderful. That's wonderful. So we'll be engaging with the chat box. Your mics will be muted for now, but it will be open at the end of during the Q&A section. So please bear with us. Please bear with us. So just to start again, good morning again. My name is Favor. Yes, my name is Favor. So today's session is about 3D laser scanning and how it's changing the future of surveying. As surveyors, we know that land is diminishing, but surveyors are not. So we have to look beyond traditional methods and adopt new technologies. So that is the essence, that is the main purpose of this webinar. So by the end of this webinar, you'll be able to understand what 3D laser scanning is, and then how 3D laser scanning compares to traditional methods like total stations for as-built surveys. You'll also be able to see how different industries are applying 3D laser scanning, and then how building information model adds value to construction, engineering industries, how your scan data can turn into intelligence for these industries. Then most importantly, you'll be able to see how you as a surveyor, as an engineer, as a professional in the build space can leverage this technology to increase your income and to raise your service value. So these are the goals and the objectives that we have for this webinar, and that is the point, that's the whole point. So by the end of this webinar, we hope to achieve these goals. So please stay with us. So let me share my screen now so that we can meet our speakers. So I just mentioned about our webinar. the webinar goals. Yeah, so right now we'll be diving right into it. So for this webinar, we'll be having two speakers as displayed on the flyer. We'll be having Mr. Emmanuel Kenneth, a scan to beam specialist. He will be speaking to us. And then we have a special guest with us, Mr. Felix Yang, a 3D scanning specialist. Will be joining us from China. So he'll be sharing his expertise with us in this session. So I'll be introducing them as they come on. So let's move on to let me introduce them now. I'll be introducing them as their section starts. So let me introduce the first speaker that we have today, Mr. Emmanuel Kenneth. So I'm delighted to introduce to us Mr. Emmanuel Kenneth. He's a scan to beam specialist at OTIC Surveys. He has extensive experience in collecting and processing laser scan data and integrating it into BIM, that's building information model workflows for industries such as construction, engineering, and facility management. Today, he'll be showing us how we surveyors, how we professionals in the built industry can leverage 3D scanning technology to increase both income and professional value. Mr. Kenneth, you're welcome.
Good morning.
Yes, good morning. Good morning.
Thank you very much.
Please, you can share your screen and start. Thank you for joining us today.
You're welcome. Okay. Hi, everyone. I'm trying to share my screen. Share window. Yeah, maybe I have to share my entire screen. Can't find it. Right.
Is it the same slide you shared with me? I could help you share it.
Okay, can you see my screen?
Yes, boys, doubled. Okay, yeah, I can see your screen now. I can see your screen now.
Okay, so welcome everyone. So I want to introduce you to the concept of 3D laser scanning. I don't know if you can hear me. If you can hear me, can you just type an emoji, maybe an emoji of waving hands? Okay. Okay, so I'll move on. So imagine that you go to a site and they say what you need is as built. What you need is they want you to detail the whole site, and then give them topography. And the site is spanning, maybe, let's say, 10 acres of land. How long will it take you? How long will it take you to achieve it? It can go as long as 3 weeks, 1 month, 6 months, depending on how detailed the site is. But laser scanning is a technology that was produced to solve that problem. This 3D laser scanning. What is 3D laser scanning? So 3D laser scanning is a technology that uses LiDAR. LiDAR stands for light detection and ranging. So it uses LiDAR to capture detailed data about the real world. It sends out laser beams to surfaces that are around, especially a surface that have line of sight to the laser. When the laser hits an object, it bounces back to the scanner. The scanner will now record it, will measure it and check how long did it take the light to return from the surface back to the scanner. And it will now calculate the angle of the light beam. All this is being done under 1 second. 1 second. All this is being captured 1 second. From this activity, it calculates the position of objects as it is passing, as you are carrying it to pass, or as you place it, as it is scanning, it is calculating, and it is recording the position by sending beams. These beams are recorded as points. So now, if you now have a lot of these beams, you now have what we term point cloud. Point cloud is like when you have a cloud of points. Cloud of point is like having a digital copy, a digital twin of wherever you have scanned. What you are seeing in reality, you have it digitally. That's the concept of laser scanning. As long as the laser beam hits an object, it will record it. If the scanner has the capacity to capture video or photograph, it will capture the color, and then you will be able to see it as it is. You even see it, and you'll be able to recognize it to create a digital copy. Excuse me. So there are two types of laser scanning. We have the laser scanning that is terrestrial, and we have the one that is mobile. The mobile scanning is the one you carry along and you move with the scanner, and as you are moving, it will be scanning. But the terrestrial, you have to mount it on a tripod. It will go 360. It will scan 360. You move it to another point of line of sight to scan 360. So that's the terrestrial scanner, laser scanner. The mobile one is the one you hold it in your hand, mount it on your back, or you mount it on top of a vehicle. It's a mobile, anyone that allows you to move. So the mobile scanners uses the technology called SLAM, simultaneous localization and mapping. So it uses SLAM to calculate its position while in motion. So it is constantly sending a beam and then using IMU to say, okay, I'm at this height, and then it will calculate and then readjust the point, because as you are moving, you are constant motion. So SLAM, the laser scanning of mobile scanners incorporates SLAM with IMU. So why are we bringing this to surveyors and engineers? Why are we saying, surveyors, engineers, you need to jump in on this new technology? Because of the number one, speed. Laser scanning captures about 3,000 to 1 million points per second, depends on the capacity of your scanner. From 3,000 to 1 million points per second. Imagine the amount of data in 1 million points. So which means you can be done with a site as big as 60,000 square meters. You can be done with it under 45 minutes by just walking around, by just moving distance that will cover the whole area. So number two, the accuracy. That's millimeter level accuracy. Even when the structure is complex, if you scan and you take tape or GNSS and you measure it, you will be marveled at the accuracy. You scan a house and you carry tape and measure the distance from pillar to pillar, you will be amazed at the accuracy. Number three, safety. You capture from a distance, even in sites that are dangerous, busy roads, industrial plants. You don't need to go close. Some scanners has distance of like 100 meters. Some has up to 300, some 600. As far as 100 meters range, you've captured the detail of everything within that 100 meters radius. It is efficient. It reduces returning to sites. When you scan and you go, even details you don't need will be captured. You don't have to say, hey, we forgot to detail drainage. Oh, no, we forgot to take inverts of the drainage. We forgot to take some pillars. There's some pillar we miss. No, as long as you are passing and you have line of sight with the mobile scanner or with the scanner, you will capture every detail in its line of sight. Number 5, it is interdisciplinary. So you can use it in construction, you can use it in oil and gas mapping, you can use it in monitoring bridge and complex structure, you can use it in as-built surveys, you can use it to preserve heritage, you can also use it in crime. Yes, forensics. If somebody commits, if there's an homicide now, you can use laser scanning, scan the place, and then you'll be able to look at the site, the crime scene in detail, because you've captured a digital copy, a digital twin of the crime scene. Even if the crime scene was cleaned up, you can still always go back to your data. So it is a new source of income. Why? Because every year, surveyors are increasing. Surveyors are getting registered. A lot of surveyors are in school, preparing to venture into the industry of surveying. But land is not increasing. Land is constant. Land is constant. Surveyors are increasing. Land is constant. So to get to a point where disaster survey will be a thing of survival of the fittest, and a lot of people will be wiped out because they refuse to adapt. Even there are some governors that are even trying to take away cadastral surveys from surveyors. Some governors that are trying to ban survey outside government. We should not wait until one person that doesn't know the need or the importance of surveyors to come out and then pass one bill that will just wipe the profession out. what will we do? So we have to adapt. Technology is bringing new and efficient way to do surveying. So what do you use laser scanning for? In laser scanning, you can use it for surveying, you can use it for engineering, you can use it for infrastructure, heritage, oil and gas. In surveying, you can generate topographic maps from point cloud. You know, when you do topo with GNSS or total station, interpolate it. The interpolation means that you want to create a point cloud, enough data for it to be able to see the topography of the, to calculate the topography of the soil or the environment of the site. But with laser scanning, you don't need to now do interpolation. You just generate DSM, generate DTM, generate directly from the point cloud. You can also just use the point cloud to do cadastral survey. You can map out the boundary of the site. You can do as built. Check there's building here. You map. You detail the building. You map out the perimeter. Surveyors can also create built BIM model of existing buildings. BIM is building information modeling. Although surveyors are not really into BIM, the engineers are the engineers and the architects are really the people that are dominating in BIM. So, but if you know what laser scanning is, you're able to now learn BIM, building information modeling, and then you'll be able to regenerate a structure that has been built. Then they can now use it to check where do they need renovation, where do they need maintenance, where do they need fitting, retrofitting. In construction, you can use the BIM that you've scanned to BIM. Scan to BIM. It's called scan to BIM. When you scan, you turn it to BIM. I use the BIM to check whether these builders, the structural engineers, are they following the original structural plan? Are they following the architectural plan? Is the wall where it's supposed to be? Because in my short stint of scanning, I found out that the walls of some houses are not straight. If you look at it, you will be looking at it that it's straight. I've discovered that most times the walls are not straight. The pillars are not straight. The beams are not perfectly placed. There's lapses. So in infrastructure, you can also use it to scan roads, bridge, tunnels, plants, and then regenerate or check what you need. You can map out, you can do CAD from the scan, and then you're able to finish structure. In heritage, you scan it, you turn it to BIM, you preserve it, you document it. For example, I saw a video of the amalgamation house. The amalgamation house that they used to sign Nigeria in 1914. It has been destroyed. That's an heritage site. What laser scanning can do is that we can scan the structure, look at the places that are bad, renovate it. In our gas facility mapping, you can use laser scanning to calibrate tanks. You can use it also to check for leakages, because once laser is scanning, it assigns a particular color to each point according to the reflective surface. So if you scan the tank and maybe the scanner scans a part where oil is coming out from, it will give it a unique color in RGB. You will see that every other place is blue and green. But there's one particular place is looking red. You know that there's leakage in this side. So that's how it can be used in oil and gas. It can also be used for pipeline. So in hotels, you can use it to create digital twin that you will now use for maintenance, innovation. You can use it to incorporate smart technologies, because it gives you accurate scan data, spatial data. And gas facilities, you will improve safety, asset management with precise 3D mapping. You'll be able to plan expansions with reduced downtime. In deformation monitoring, you will detect subtle shifts, structures, slopes, dams, and tunnels over time. It is essential for safety and early warning signs. So if you scan, let's say, a dam today, and you come back the next time and you scan it and there's crack, it will show. The crack may not be visible to your eyes, but as long as the laser scanning picked it up, you will see it and you're able to now know the necessary step to take, whether it is to renovate or evacuate. So it is good for quality assurance and assessment to verify that construction matches design specifications. To achieve millimeter level precision in as-built verification. Able to now use it to say, structural engineer, project manager, project director, these people do not follow the design plan. In bridge and infrastructure monitoring, you scan bridges, roads, and tunnels to assess structural integrity. You will enable preventive maintenance instead of reactive repairs. So when you scan the bridge, you're able to know where boats have lost, where boats are not as losing. You're able to know where there is now a slag. Instead of now until the bridge starts shaking before you now start doing repair, you're able to have seen it when you have constant scanning procedure. So you can also use laser scanning to calculate volume and stockpile. You can use it to compute volumes. You can use it to compute stockpiles. You accurately calculate stockpile volumes and gravel, aggregate, soil. It replaces that traditional one where you just pick some parts You pick here, you pick here, you pick here, because you cannot go around. This one, it will pick every piece of sand, gravel, point cloud, we target it as long as it is showing on the surface. Now you have points on that distance. The accuracy will be high. Instead of that one where there have to be interpolation or triangulation to make up for those spaces that you didn't measure. So it will save you time on your earthwork, your query, your landfill surveys. It will provide you with cut and fill reports, so you can now use it to track changes over time. It is a plug and play something. Just cross-section out the stockpile or the cut area, map the boundary. Then you click volume compute. It will just automatically compute it for you. So what are the workflow? You go to field, you scan, you register multiple scan. If you are doing multiple scans, different scans that you didn't join together, you need registration. After scanning, you go to the office. You do point cloud processing, you clean, you model, and then you produce it in CAD, or you can give them in 3D, in volumes, reports. Depends on what they want. So the software you need: Slam Master, Revit, Autodesk Recap, AutoCAD, and some other ones. But these are the main ones if you want to be doing scan to BIM or scan to CAD. So I want you to generate accurate 3D model and expand your GIS data set, because laser scanning with OTIC gives it a geotag. Unless you are using just the laser scanning without OTIC, if you incorporate OTIC to give you a geotag, so each point in the point cloud now has X, Y, and Z. The X and Y is the position of where it is on the ground. The Z will now be the height. It will now use to tell you whether it is a ground floor or a table or a wall. I want you to take advantage of this opportunity for you to enter into laser scanning in surveying or engineering. And engineering, what you need is the hardware, the software, and the training. Hardware is the laser scanning, the software is the software used to clean, register, compute, turn into model. What are the costs and what are the return on investment? Now, the barrier, the field of laser scanning in Nigeria is still open, like it's not crowded. In short, there are not even up to 5 people in Nigeria that does laser scanning at this moment. And not up to 5 companies that does laser scanning as at this moment. So the entry is still, the door is still open. So before it becomes crowded. So you can start small. You can first of all learn the software parts. Then you partner with people that has laser scanning, like OTIC Surveys. Scan, they give you the data. You use your hand to process it. model it, or you can rent. So I hope that I'll be able to open your eye into this world of 3D laser scanning a bit. I am kind of in a hurry, so that's why the slide is a bit not detailed. So it's just so you can see I'm on reflective. So I'm on a project, and it's a laser scanning project, and has built survey. And the situation is that the builders and the structural engineers didn't follow the original structure plan. So they're trying to locate all the mistakes, and using total station would be tedious. We can stay here in like 6 months, but with laser scanning, IS 2 weeks, we've gotten all the thing we need, and we are off to processing. So thank you very much for having me today. You can drop your questions.
Thank you so much, Mr. Kenneth. That was very insightful. Lots of practical insights there. Thank you for that valuable presentation. I don't know, maybe if you have some minutes, because I know some people will have questions, but we can't take them now because Mr. Yang is already waiting to present as well. So thank you so much for your time and for sharing that with us. So if you enjoyed that session, I want to see your engagement in the chat box. Tell me what you learned. What did you pick from what he said? What interested you the most? What caught your interest the most? Please drop it in the chat box so that we can go to the next session without any more delay. And let me see your engagement. Let me see your engagement in the chat. Okay, I learned a lot from Mr. Daniel. Let me see more people engage. Please don't forget to drop your questions in the question and answer session, please. What about other people? What did you learn? I hope you heard him loud and clear. There was no break whatsoever, no connection issues. You heard him, just type I heard him. If you heard him, just type I heard him in the chat session. You can say I enjoyed this session. Just type something in the chat session, please. Right, Razak, thank you so much. Thank you so much. Okay, let's go on to the next session. I would like to introduce to us Mr. Felix Yang. He's our international guest on this session. He's a seasoned 3D laser scanning specialist with years of experience in reality capture. He works with ComNav Technology, applying laser scanning solutions globally. Mr. Felix will be introducing us to one of the key tools used in 3D scanning and how it can be applied in real-world projects. Please, I don't want you to get distracted. I want you to focus and gain everything you need to gain from this session. So, Mr. Felix, I'll be allowing you to present now. Okay, Mr. Felix, you're on now.
Okay, hello everyone. Welcome to join this webinar. Now I will introduce work conduct and what is slim technology. Okay, I will show you my share my screen. Okay,
Can anyone see that screen?
Okay, if you can say my screen, please. Send the news, send the information
in the chat box.
Yes.
Okay.
Okay. Thank you. Thank you. Now we can start. Okay. The first part. Uh. uh what is SLAM? SLAM. Yes. SLAM means simultaneous localization and mapping. It's one of the core technologies in fields such as robotics, autonomous driving, and AR, VR. It solves the problem of how a device can determine its own position when constructing a map of the surrounding environment in an unknown setting. Similar to how humans, when in a unfamiliar city, judge their location by observing buildings, road signs, environmental features, and at the same time mentally draw a simple map. So we how to do collect SLAM data. First one, equipment is installation. Yes. So I will show you some video. Okay. Let us see it.
Yeah. Anyway. 这东西给它展示一下。有一个快递，不用，就这样，挺好啊。是那个资讯，恢复质量，恢复质量的东西。Back，我们没有对这东西命名是吧？很多。 背负 back backing。是。
Okay, this is a back kit.
Continuous. 这个事情没有捡起来。
然后要上那个架子。看到。OK。
电池有忘记捡。
Okay, this device can help you handle this slim stable.
可以了吗？
好看。Step 2, we need to connect the software. Step 1, search Bluetooth number, check this device list. And step 2, configure network password. Okay, I will show you another video. Okay, you can see it after initialization, we can start work, and this screen will show your cloud cloud point. Fine.
这考虑掉，我觉得那还少一点。
没关系，我们只看一点。
听到了，你怎么？哎，他能看到我们吗？问一下他。
能看到我，应该能看到我。哎，这直接开始。直播从开始。OK， next one, we should do a device initialization. Okay. So in the software, you can see a go. So click the go to enter the scanning standby page. The app will prompt the static initialization has start, and then it will start a 50-second static initialize countdown. After initialize, so we can start work. In start work, you need to keep the device stable during initialization. When initialization is completed, left is device slowly. Okay. So we how to ensure data. Sorry. Okay. 我得把这个关掉一下。哎，因我读啊。OK， 继续。OK。我从下一页。
So this slide conclude the procedure of how our device to collect the SLAM data. So the first step is installation of the equipment, and the second step is to connect to the software, and the third step is device initialization, and the final step is to start working. Okay, so in this slide, it shows how to ensure the data we collect, the quality of the data we collect. So during the scan initialization, first before starting the scan, so place the LS600 on a flat and stable surface. So you can see on the last slide, we use a back kit. We wear the kit to keep the device LS600 flat and stable. So second, to avoid any shaking or vibration during the initialization phase. So if needed, you can gently hold the scanner to keep it stable. So next step, make sure there are no people obstructions in front of the lidar sensor. So next step, after initialization is complete, slowly and steadily pick up the device. Avoid the sudden movements. And the final step is try to initialize the device in areas with rich features, like walls, furniture, or nature surroundings. Avoid open fields, large glass surfaces, or areas with many moving objects. A well-featured environment ensures accurate and stable initialization. So during the scanning process, so first, while scanning, avoid quick turns, sudden stops, or rapid swinging of the device, especially when turning corners. These may affect mapping accuracy. And next, always hold the scanner upright and steady. Do not tilt the device horizontally, particularly when the RTK module is mounted, as it may affect satellite signal reception. And next is indoor multi-room or multi-floor scanning. So when scanning multiple rooms or floors indoors, open all doors in advance if possible. And when passing through doorways, move slowly and pause briefly at the doorway to ensure both sides are captured clearly. And third, if the door is closed, slowly turn around before reaching the door. Keep your back towards the door. Open gently and proceed slowly into the next space. In this slide, it tells the control point mode precautions. So first, when placing the device on the ground to mark a control point, avoid hot impacts or strong vibrations. And then after marking the point, lift the device slowly and steadily. Thus, handling may cause errors in the recorded position. And finally, if you plan to end the scan right after collecting the control point, please wait at least 15 seconds before stopping the recording to ensure all data is properly saved. Okay. So in this slide, it's an introduction about the software that connected to the device LS600. So I see in the chat box, someone told that you can't see our current slide.
你再试一下，你再试一下。
Okay, how about this time? Can you see the slide?
Yes.
Yes, okay. Yes, okay.
Okay.
So we will continue. Okay, okay. Thank you so much.
现在是到哪一步了？
现在整个屏幕码例子，这样子它就我们就随便投。
你要跟他说什么那一步？现在刚刚 PPT 走到那个什么了？
对，
走到软件了吗？
我们的软件，我们从导入数据开始。
Okay, so we will to demonstrate the process of data collect. So first we will use our software, and we click file and click import data.
PPT 给他导进去看，他们有没有用过这个？
原来兄弟们好。
看完是吧？
这个是原始。
对，这个是遇到的是解散后的。
解散后的。
对，遇到的解散后。
我要放，要不要放这种填？对。
你下面的流程都是就给他看数据，然后
对对，
这不是介绍这个东西吗？介绍完之后让他们提问题好了，太复杂的事情了，他们肯定不会用过的。直接跟他说这个软件有什么功能，比如说我们可以浏览，可以建 Max 模型，因为他刚刚提到的那个东西。 Can you really put the presentation mode 是什么意思？presentation mode 是
这里面那个
自由是吗？
就是把那个
延时
对延时模式。
这方面
用一下。
Okay, so
啊，出现了。
没关系，我跟你说怎么搞。现在这个可以删掉 ，yes，然后这个是要看那个数据是吧？
感觉那个可以。
我来简单跟他说，那个讲一下，这扫到哪儿？这是隧道的，
隧道
隧道用英语怎么说
mini tunnel，mini
？Many tunnel，对。Okay, guys. Now you could see my screen. Now we can see many
mini tunnel。
我直接说。And now we can see the point cloud. Now use this software, we could can input the point cloud data, and we can 浏览
browse。
我直接说你给它翻译吧。
好，
就是这个软件可以浏览和就是可以结算和浏览数据。
Okay. So we can input the data we collected into the software, and we can browse the point cloud and to calculate the raw data about the data we collected.
然后我给它介绍这些工具页，我简单跟你说一下，前两个是用来配准的。
Okay, so here's the introduction about the software. So you can see its tools. The first tool is
这是手动配准的，这手动选点配准的。就读它的单词。
So first one is manual registration, and the second one is SCP registration.
然后这些是预处理的，这些都不用了，我直接跟他说这个做这个分析，剖面分析啊，这个也可以说一下，就是转换格式的。
Okay, so data management, you can transport the data you collected into different kind of format.
然后我们介绍一下这个是剖面查看，然后选择这个东西之后 ，now can select the cloud point cloud，然后now we can see is select and we can vary it. Okay, we can get this.
Yes, by using these tools, we can have a side look of the point cloud we collected, and we can see we can measure the distance about the different point we collect.
Application, the mass function. We can change the point cloud to the OBJ mass module and OSGB, OBJ or OSGB. 他们这个在这里，network 对，其实更容易聊就这些吧。然后我们下一步要跟他干啥？是提问题吗？还是什么？
是就讲一下这个精度和那个就是
，OK， 那还是 PPT 吧？
其实是不是 PPT 这里的？
可以继续。
继续。
那 OK， 那你还是这个的可以吗？在这里。 然后我要放颜色，要不再看一下那个肤色之类的，跟我讲，颜色，或者说边讲边放。我觉得，边讲，对，因为直接看这里的吧。从那个水。Okay.
Hello, Mr. Yang.
Okay.
Yeah, can you hear me?
Yes.
Yeah.
Okay. Please, you don't have to like go through the entire software process. You can just the slides you sent me. You can just go through them and just let us elaborate on the slides. You don't really have to go through the entire software process because we have surveyors and some of them have to return to site, so we wouldn't want to keep them long.
Okay, so we just go on with our PowerPoint. Okay.
It's your PowerPoint, please. Thank you so much.
Don't worry, you're welcome. 不看软件，
讲 PPT。
对，继续 PPT 读完的。
也是过个流程。
So can you see the slide?
Yes, please, but
Okay.
can you make it full screen?
Okay. We continue our presentation.
Okay.
Can you make it full screen? Okay, yes, thank you.
Okay. Don't worry. Okay, so our product addressing core industry pain points. First one is time-consuming post-processing. You know, some of the device may cost a lot of time to do the post-processing, and our product can easily do the processing procedure. And the second pain point was inconsistent GNSS signals. And the next one is limited color fidelity. So for our product, over 60% of scanning projects face costly rework due to incomplete data. LS600 eliminates this. And the second one, we counter GNSS challenges. So varying CM level accuracy, even in urban canyons and forests powered by Sino GNSS RTK. So we have our own RTK products. So by the upgrade of our technology, we can easily handle these challenges. And next is Slash's post-processing time. So real-time SLAM integration cuts processing by up to 50% of time. So now, so maybe in the old days, you may take 1 hour to post-process some of the data, and now you only have only need 30 minutes. So finally, it delivers true to life colors. So experience superior fidelity with dual 16 million pixels wide angle cameras. So you can get the fidelity colors of the things you scanned. So you can you can output the point cloud immediately after you scanning by connected to our software. Okay. Yeah. Reinventing field operations, loop-free and hassle-free. So you scan once and success every time. So GNSS plus SLAM integration and merge real-time positioning with LiDAR data. No loop closures needed, and faster completion, and up to 30% faster than before, and less field time. no rescans or realignment. And next is a smoother capture. Consistent GNSS prevents drift over large areas. Okay, so on the fly, georeferencing produces a georeferenced point cloud instantly, as we showed in the software, and live coverage feedback. We can see scanned areas in real time, adjust to avoid gaps, and adaptive scanning, minimize overlap, ensures full coverage in few passes. Yes. Okay, and we have our own Spectra color brand and unleashing the true color. So as we mentioned in the last slide, you can see the world in vibrant photorealistic detail, unlike anything before. You can see the pictures here. So here, so the last picture is the real exhibition hall of our company, and the pictures upper is the scanned pictures, and crystal clear point clouds. You can see through the pictures. The picture we scanned is really clear, and industry-leading noise reduction for unparalleled data clarity, and ready for 3D Gaussian splatting. So preparing for the next leap in realism, ensuring unparalleled visual fidelity in the future. So it's coming soon. So about our product, it's
这个就是用来测控制点来讲一下，
okay.
够多了，这个看头上这个
So the hole on the bottom of the device can help you to detect the control point. Okay, so this is the product. So the first part is the real-time SLAM. It minimizes drift, ensures stability, and inside the device, it has our standard GNSS RTK and the rapid signal reacquisition in tough areas. So with the technology of our RTK products, it can help easily to SLAM. And the camera on the side of the device enhances alignment and color fidelity. You can see our self-development SoC chips and a geodetic antenna, fast and stable signal lock. This is Spectra Fusion V-SLAM imaging system. So it enhances alignment and color fidelity. So V-SLAM enhanced the dual 48 million pixel cameras, elevating point cloud quality to new heights. And we have 190-degree multiple 2 FOV panoramic dual camera, complete data capture everywhere. So the device integrated handle design with 49 watts hours in dual cell battery. So it has it integrated the batteries in the handle, and it had a 30 minutes fast charge up to 1.5 hours continuous operation. and it's easily for change of the battery. Okay, so this is a whole introduction about the device, and the whole device is IP54 rating, IP54 rating, and it's dust and water resistant for rugged use. And the GNSS stress test is stable in obstructed areas. The thermal endurance it can use in this environment from 20 degrees Fahrenheit. It can use in from a very low temperature to high temperature. Okay, and the application we use can show the point cloud instantly when you scan in the real world, and the point cloud was shown in the application. This is the software we showed before. It can help us handle the data we collected. So this is the introduction we introduced in the last few slides. Yes. So the first picture is the sky of several different floors. In complex structured environments, LS600 maintains astonishing data stability. So point cloud structure is precise, complete, and drift-free. True quality lies in the details. You can see in the picture. Okay, so LS600 is true color rendering, vivid and lifelike. So LS600's dual true color cameras provide point clouds with realistic colors, and details are meticulously captured. You can see the picture here. So material textures are clearly discriminable. What you see in what you get is what you get for an immersive experience. This is a picture from another brand. You can have a contrast for the two pictures. So first one is from our LS600, and the next one is from another brand. You can see the difference. Okay. Yes, you can see from the two pictures, you can see the difference between our product and other brand product. Here is also the contrast between different brand. So first one is our brand. This one is also shows the difference between different brand. So our device empowering every industries, such like mining and urban renewal, like we use in the infrastructure construction and the surveying and the construction. And maybe in some countries we scanning the forest. That's the use of different industries. LS 600 topographic service, 90% faster, and with our self-developed technology, our RTK precision can reach the global accuracy, and the precision modes rapidly cartography and urban to rural different areas, the terrain independence. Yes, so this is the industry I mentioned in the last slide. It's forest scanning, and the rapid forest data acquisition, automated forest analysis, and the parameter extraction, and the streamlined workflow and enhanced efficiency. And the last one is key forest advantages. It increased the productivity and enhanced accuracy and data-driven decisions, and informed management and planning, and improved monitoring, efficient forest health tracking. As so this is used in the mining tunnels. LS 600 precision mining management, stockpile on volume, precisely controlled, and tunnel modeling, safety secured, and slope monitoring, prevention first, and intelligent navigation, mines of the future. Oh, and for the devices, we have different sizes, like 32 line, we can reach 120 meters, and we have 16 line, and we also have 32 line, which can reach 300 meters. And this kind is best for mining and large service, and the first two ones best for urban or indoors scanning. And this accessories was showed in the videos, which we can use our devices more stable. Thank you so much. Okay, so you can, if you have any questions, you can ask, and we can try our best to solve the problems.
Thank you so much, Mr. Felix. That was brilliant. Thank you for sharing some insights about the LS600 scanner, how it can be used, how it can be applied in various industries. Thank you for sharing that so much. Please, if you have questions, you can drop them now in the question and answer session. We want to address them. So if you have particular speakers that you want to address your questions, you can just tag their names. Mr. Kenneth spoke to us, then Mr. Yang spoke to us later. So please, you can address the questions to the particular speaker. So now we want to go into the Q&A session. Okay, I have a comment here from Surveyor Bello Uma. He said very educative and informative lecture. Thank you so much, sir. Thank you. Someone is asking, Mr. Ayo is asking, how much is the cost of the training? Mr. Ayo, you can reach out to us. We do training on 3D laser scanning, and then we'll talk more about that. So someone is asking, Mr. Ejiro Gene Daniel is asking, does it mean that one can use laser scanning to know how a demolished building once was? He wants to know if you can use laser scanning to discover how a demolished building once was, like the structure, how it was built, if you can use laser scanning to determine that. I think after demolishing the building, I think after demolishing the building, I think that's his question.
如果在拆除前扫过之后就可以看，但是没有扫没法还原嘛。
对，我们现在试用就是
Mr. Kenneth, you can answer.
火建筑那种。
OK，
就是拆除之前呢是可以扫的，拆除之后是没有的，它只能还原现实，它不能回溯到。
OK，
Mr. Kenneth,
so
okay,
okay.
Mr. Yang, go on.
Okay, so if you scan.
Mr. Yang, please hold on. Mr. Kenneth, please continue.
Okay, so you can
Mr. Kenneth,
can you hear me? Hello?
yes, we can hear you now.
Okay, so you can only be able to get the information of what a building once was if you scan it, if you have scanned it before it was demolished. Maybe you already have a digital copy of it while it was still standing. But once it has gone, there's nothing you can do.
Okay, that's an interesting answer because my boss shared with me a project that they did for a high-rise building. So the owners of the building were selling 2 floors in the building. So they wanted to do a scan. They want to carry out a scanning of the 2 floors to document how they were handing over the property. So you can only know if there was a shift if you did a scan before. So to know how the demolished building once was, you have to do a scan so that you can compare and be able to remodel and make a digital twin of the building in question. Thank you so much, Mr. Kenneth, for answering. Okay, this question, I will direct it to Mr. Yang. So let me allow you to talk now. So Mr. Yang, can you hear me? Yang, can you hear me?
Okay, yes, I can.
Okay, someone is asking, can 3D scanning be used to locate pipeline leakage? Can you use 3D scanning to locate pipeline leakage? Like in oil and gas
Yes.
facility mapping.
It can be used propellant leakage, yes.
Okay, it can be used to detect pipeline leakage. Thank you so much. Mr. Kenneth, are you still with us? Kenneth, are you still with us? Mr. Kenneth?
Yes, I'm still here.
Okay, another question, a quick one. Can 3D laser scanning be used to carry out layout division?
Yeah, what it can do is that you can use it to map the perimeter. Then you can now do your parcellation. It's not like there's a software there's already a software that does automatic layout division. So what it does is it maps the surrounding. Maybe you can now put it inside the software by plotting the perimeter, put inside the one that does the layout parcellation, and then you have your final deliverable.
Okay, thank you so much for answering. Someone is asking, can it scan below the ground level or water? Can it scan below ground level or water? Mr. Yang, you can answer. Mr. Kenneth, you can answer.
是什么？
在那个地底下。
地底下可以，但是得有空间点附坐标。
Yes, it can be used below ground level, but you need to put some control point in the ground, and you
Okay.
can sever this point, and you can into the below ground. Yes.
So you're saying it can penetrate the ground and it can penetrate water. Is that what you're saying?
Trees penetrate，
Penetrate the ground
就是
or
不能穿
water?
透地面，
Oh no
不
no
能穿透
no.
地面。
Yeah, we can't below in ground below ground. Yes.
Okay,
We can't.
below ground.
Yes, we can. We can't. Yes.
We can't. Okay. So for building, what is the range of penetration for buildings? What is the range of penetration for buildings?
你跟他说一
Like
下，
how? What is the depth of
它只能
penetration?
记录表面的东西，它不能穿透某些东西。
No. I means we can't below in ground. We can't below in surface. We just sever building surface or some project surface.
Okay.
Yeah.
So
yes,
what it means is that what it meant is that
Mhm.
you can only scan below the ground surface. Let's say if you have an opening, like a basement or
Okay.
tunnel under
Oh.
it cannot penetrate the ground if you are standing on top of it.
Okay.
You can only scan surface. The laser sends beams to the surface and reflect it back. So if there's a surface, it cannot go below it.
Okay. Okay.
It is not.
Yes.
You
You
have
are right.
You have to scan the ground. You put control on the ground. You scan
Okay.
it. You go under through the basement or through the tunnel. So there will not be a relation between the main ground floor and the below the ground floor, below the ground. So
Alright.
that's how it works. It cannot
Okay.
do penetration. That one is ground penetration radar.
Oh, GPR. Okay. Okay. Someone asked, can the scanner inside building? I think he meant, can you scan inside building to know? This is confusing question. Can you scan inside a building to detect electrical cable damage? Can you scan inside building to detect electrical cable damage?
Yes.
Kenneth, you said?
Yes, you definitely can. You can.
Okay.
You can scan, and you can scan just because you want to model the electrical structure.
Okay.
You can scan because you want to model the structural frame of the building. It's not only limited to architectural. You can have the architectural plan. You can remodel the architectural plan. You can remodel the structural plan if you just want to focus on beams, columns, slabs. You can remodel the electrical plan because all this they have plans. The electrical plan, if the mechanical plan, mechanical works, if they are visible, you can also do that one too. As long as it's visible, you're able to remodel it.
Okay, that's interesting. Okay, another question. I think is a very funny question. Someone said he tagged forest scanning. Then he asked, can he scan animals and determine their position? I think Mr. Yang, you mentioned something about forest mapping. So I think he's asking if the scanner, if the scanner can scan animals and determine their position. I don't know. Is that even possible?
Yes, if animals don't move, you can scan everything. But animals always move and run and move. Yes, so you can't scan this animal or everything move things like a car, plane,
Oh,
or it move people. Yes, you can scan everything if it will move. Okay.
Mr. Yang, thank you for clarifying that. So, Mr. John, you can see that animals too can be captured if they are within the line of sight. So, object has a plant, has a moving car, has a person, has the animal within the area of interest, within the line of sight of the scanner, it will be captured. Thank you
and
so
they
much,
mustn't,
Mr. Yang.
they mustn't move.
Yeah, they will not move. They won't move.
Because during processing, moving objects are being is cleared off.
Okay. Okay. So as far as the object is stationary, it will be captured. Thank you so much. Someone is asking, will the PDF of the presentation be available? I would also like to know the cost of buying. I would also like to know the cost of buying.
PDF 那个 PDF 其实
Buying or renting the mobile scanner. Additionally, can it be mounted on a UAV?
有我们的吧？
So, Mr. Caesar, yes, the recording will be available. And, you want to know the cost of buying and renting the mobile scanner. Yes, the PDF will be available as well as recording. Then the cost of buying and renting the mobile scanner, you would have to reach out personally to us. I will drop my number in the chat box, so you can just message me there. Then the last question. Additionally, can it be mounted on a UAV? Mr. Yang, can you mount the laser scanner on a UAV?
Yeah, no.
No.
Now we can
Yes, the scanner is very
just
heavy.
just handle.
Yes, just handle. We just handle you it. Yes.
Yes, we should keep the device stable, so we cannot place it on the UAV.
但是可以放在车上。
Yes, and it can place on the car. On the car is okay.
给你发电话呀。
Thank you so much, Mr. Yang, for answering that. I have a question from Surveyors DVC. Hi, Surveyors DVC. Thank you for joining us today. So your question is, you want to know if the scanner or indeed any scanner can be used to scan inside a cement silo through a 6-inch pipe leading into a cement silo. Wow, this is quite a technical question. Mr. Kenneth.
You say what? You want to know if a scanner can be
used to scan inside a cement silo through a 6-inch pipe. That'd be 6 inches pipe. That should be 6 inches pipe. A 6-inch pipe, a 6 inches pipe.
Yes, it's through a 6-inch. The scanner is kind of big. I don't know what you mean by 2 a 6. If you are going to pass the scanner inside the 6-inch pipe, or are going to use the 6-inch pipe to carry the scanner inside the silo.
Let me try to unmute him so that maybe he could elaborate on his question. So we're in DBC. I'm allowing you to talk now, so you could maybe ask your question better. You can just unmute yourself and let us understand what you're asking. Hello, sir. Surveying GBC. Hello, sir. Yes, we can hear you. Please go ahead. So we can hardly hear you. Your network isn't stable.
Okay. Can you hear me now? Is it better
Yes,
now?
yes, it's better now. It's better now.
Okay. Okay. I said a cement silo is an enclosed, it's an enclosure. So the only access to see what is going on inside the silo, to know the position of the materials there, is through that 6-inch pipe. So that's why I'm asking: is this scanner, but this scanner is big, or any other scanner for that matter, that can pass through that that can be put through the pipe, then to be able to see the opening of a cement silo? That's my question.
Okay, we get you now. Thank you, sir. Mr. Yang, you dropped a
welcome.
question. Okay, you just answered question. Mr. Kenneth, do you understand him now? Um,
明白他的问题，其实我没有明白他的问题。
Yes, yes.
So he's asking if you can use the scanner through a 6-inch pipe to detect cracks in a cement silo.
水泥上裂缝太小了吧？我们应该
In fact, its scanner is very big. I think
Okay.
2-inch is
Maybe too small.
maybe too small. We can into inside. We can into inside, so we can't
Scan the
scan.
inside of the pipe.
Okay, but are there other scanners, like maybe another product you have that could maybe get into the 6-inch pipe? Because I think that's what it's asking too. He wants to know if another scanner, if not the LS600 you showed, can do that. Did you hear me, Mr. Yang? Did you hear me?
Yes, yes.
Yeah.
So is there a smaller size scanner that can maybe be able to pass through the 6-inch pipe? Do we have a scanner like that?
No,
No,
两英寸太小。
it has multi-channel, so
Okay.
you want to make it small. It's very difficult. Now, most of scanner is very big. Like
Big.
Yes, not just like the LS600. The scanner from the other companies also
Yes.
have the same big size, because it
Big.
must contain the RTK units and cameras and the different kind of devices. So the size of it must be more bigger than 2 inches.
Okay. Thank you so much. Mr. Surveying GBC, so your question has been answered. There's no scanner that small right now that can pass through a 6-inch pipe. Yeah. So someone is asking, Mr. Kenneth, can you help me with the name of the software that does automatic layout? Someone addressed the question to Surveyor Kenneth. He said, can you help me with the name of the software that does automatic layout? I don't know if Mr. Kenneth is still with us. Mr. Kenneth, are you still with us?
Yes, I will I will circle back on the name. I can't remember it now.
Okay. Okay. Please, in what form does the result come after scanning? Is it an image form or video? I think Mr. Yang answered that, saying it supports LAS and JPG, so it's image form. Image form. So it's image form. Then for the point cloud, is being saved as LAS. So, oh, Mr. Joseph is asking if the instrument is good enough to locate terrorists, thereby is the nation's problem. I don't know, can laser scanning be used to locate terrorists? Can it be used to fight terrorism? I know Mr. Kenneth mentioned something about forensics. So, well, I don't know if terrorism is part of it. Mr. Yang, do you think so? What's your thought on this?
Yes, I think no. I think no.
Oh, no.
Yeah.
Oh, okay.
Maybe you
Okay.
can use yes.
Maybe I can use what?
It's just a device to survey. It's just a device to survey.
Yes. So for the scenario, like in the crime scene, you can use this laser scanner to scan the crime scene, and to keep it at the GPG or less or some sort of the format of the file to keep the crime scene. But we cannot use it to find the terrorist because we need to use the device to scan. So maybe we can do, when we use the scanner, we scan the terrorist, we can locate it.
Can't hear you. We can't hear you.
Okay. Sorry. I was muted. Okay, Mr. Joseph, Mr. Yan just confirmed that you can use it to locate a terrorist, but you can use it in crime scenes for forensics to preserve a crime scene for further investigation, but you can't use it to locate terrorism or fight terrorism. So I hope that answers your question. Okay, I want to tag where I'm trying to locate the question. Okay, that came from Mr. Caesar. Please, the number I dropped in the chat box, please message me so that Mr. Kenneth can reach out to you. Mr. Kenneth can reach out to you there, so he can let you know the name of the software that he uses to do automatic layout. I hope, have we exhausted all the questions? Is that all that we have? Any more questions? Have more questions? Okay, Mr. Kenneth has dropped the name of the software. It's TestFit. TestFit is the name of the software. TestFit is the name of the software. Thank you, Mr. Kenneth, for taking time out of your busy schedule to join us today and share from your wealth of experience. Thank you so much. Any more questions? Any more questions? Mr. Joseph, you said yes. What's your question, please, so that we can address it and quickly bring the session to a close? Please have in mind that the recording will be sent to you. It will be uploaded on our YouTube channel. We'll send the link to the YouTube channel where we'll be sending the recording for the webinar. So you click on the link, it takes you there, and you can have a copy of the recording. So please, at the same time, do check us out on our YouTube pages at Josotech on YouTube. Please check us out on Twitter, the same Josotech OTIC Surveys, on LinkedIn. Follow us to be updated on the latest technology or what's new or what's happening, and then follow us to get updated on our trainings, because we also do trainings for all these equipment, for all these survey activities. So follow us to continuously be updated. Any more question? Any more question? Okay, none for now. I want to say a very big thank you to everybody for joining us today. I know it wasn't easy. It's a Tuesday and we have projects, we have things to do, but you took time to join us. And I'm sure you must have learned one or two things from everything that we said today. Thank you so much for joining us. Thank you for your engagement. Thank you for your questions. Thank you for staying with us till this time. Thank you so much. I also want to say a big thank you to our speakers, Mr. Kenneth, Emmanuel. I know you're on site right now, but you still took time to join and to share with us your expertise from your wealth of experience. Thank you. Mr. Yang, thank you so much. He's our special guest today. I want to say a big thank you to you and your friends. Can you turn on your video so I can say thank you to you and your friend? Yeah, thank you. I want everybody to know that they're actually joining us after their work hours. So they're off work right now, but still they made time to join us. So thank you so much. Thank you so much. Thank you so much. Thank you, Mr. Felix. Thank you to your friends as well. Thank you so much. I also want to say big thank you.
Questions, please keep in touch.
Okay, yes. I also say big thank you to my company, OTIC Surveys, or company I work for, company I work for, OTIC Surveys, who allowed this program to be in partnership with OTIC Technologies. So they approved that we have this session, and I'm really grateful that we did. I've learned a lot, and I'm sure you did so too. So thank you. So please, we'll send the recording shortly. You get it today. Yes, you get it today. So please check your emails. We'll send the link to the recording. So until next time, please follow us on our social media pages to get updated on our webinars, on our trainings, on everything that we do. We don't want to leave you behind. We always want to go with you every step of the way. So we have drone trainings, we have trainings on bathymetric survey, we have trainings on laser scanning. We have a whole big package. Like is huge. I can't even mention everything. So please, if you want to know more, I dropped my number in the chat box. Please reach out to me. You can still search for us on social media, reach out to us, and we will get back to you as soon as possible. So until next time, stay knowledgeable, stay fit, stay positioned, to maximize all the opportunities around you. My name is Favor, and it was nice having you on today's session. Until next time, bye.